Hey there, it's Max, and this is the conclusion to the Unlink series of challenges. So I mentioned this in one of the solution videos, but I still think it's worth calling out. In this video, this technique is mitigated, and in order to actually make these possible, I had to recompile libc with changes that actually just remove those checks entirely. I compiled a bunch of versions, custom versions of libc that had no optimizations on, just to make this a little bit easier for debugging and also make this technique possible. So the actual remediation of this is kind of clever. It's just making sure that we're going in a circle. So if I go from FD's um, BK, it makes sure that BK's FD are the same. So the pointers that it actually points to are exactly the same. I think it's a pretty clever check, and it works really well. But you're probably wondering, Max, if this was mitigated 15 years ago, why are we talking about it? And that is a pretty good point. And to that, I think a lot of binary exploitation is knowing where things have started and then where things are going. And this was a really important technique at the time. It's one of the first heap exploit techniques that was developed. It was written in a Frack article years ago that talked about this. I think that was pretty cool. In terms of difficulty, though, I think this is actually a pretty difficult technique. I think I made this a lot easier by having just fill in the blanks. But I remember trying to exploit this for the first time in the Shellcode Hacker's Handbook, and it was really difficult. It took me quite a bit of time and banging my head against the wall to get working, and that was pretty frustrating at the time. So I think understanding the history of this, where things have started, where things are going, is really important for this. And linked lists are still used in other places too, not just glibc. So having this understanding of a write, what, where primitive is also a really important thing as well. So there's also another technique called Unsafe Unlink that can actually bypass this check. It's kind, although it's called Unsafe Unlink, it kind of has lost um, the unlinked flair of it. It's not a write, what, where primitive. It allows you to write to the pointer that we're using to fake this chunk. It's a really strange primitive. I do have slides for it in here if you do want to go through them, and there is a demo as well in the demos folder that allows you to see the technique in action, and it's fairly well commented as well. I'm not going to go through it. This technique is really unrealistic, and I don't like techniques that are unrealistic. There are a lot of really crazy heap exploitation techniques that I think are really cool and awesome, but they do require such esoteric, unlikely scenarios. I don't think they're very useful, and I think this is a good case of that. So if you want to learn more, you can read through the slides, you can read through the articles I've linked, and play around with the demo, but I'm not going to go through it in this course. There are some similar techniques to Unlink that I think are fun. The House of Ehrenhar, I never knew how to say this, and now I have to say it in front of you, which kind of sucks. Just trying to prevent or say names at a graduation for all different ethnicities, and you have no idea how to pronounce anything. That's how I feel with this. House of Storm is also kind of interesting. It requires you to corrupt some free list pointers in very particular ways. I think it's pretty fun as well. So I hope you enjoyed this module. I think this is one of my favorite ones that I wrote. Just understanding the history and recompiling libc, getting it working, having the different challenges was really fun to me. So hope you enjoyed, and see you in the next module.